Hello, grade 10s. Oh, it's a snow day and I'm wearing my athletic shirt. Shouldn't really wear that, should I? You probably noticed I've been wearing this zip up last, this whole unit of videos because today's a snow day. And I am honestly recording all my videos for this unit, as many as I can today. So that is why you've been seeing a lot of this zip up. Anyway, hi, how are you guys? We're going to solve some more problems today. We are going to do two types. We're going to do mixture problems, and we're going to start with our distance, speed, time problems. That is going to be your most challenging type of problem, but I know you guys, you got this. You can do it. I can, I will. Did you see my shirt? You can, and well, you will. All right, so let's start with some mixture problems though. So there's two types. There's usually a type with percentages and a type with money. So I'm doing one of each for you guys. All right, so Mr. Fittler has, why isn't this working? There we go. Has a bottle of 5% acetic acid and a bottle of 10% acetic acid. How much of each should he use to make 250 milliliters of 8% acetic acid? So let's think about this first. Which does he need to use more of, the 5% or the 10%? Excuse me. Well, let's think. If he used an equal amount of each, what percent acetic acid would his mixture be? It would be at 7.5%, halfway in between, because if you have half of 5, half of 10, that would get you a mixture of 7.5%. So he must have more of the 10% acetic acid in there to get it up to 8%, higher than the middle point. Just something to think about before you get started. So what do we not know? We don't know how much of each he should use. So how many milliliters of each type of acid, of each concentration he should use. So we'll say let X represent amount of 5% acid in milliliters. Okay, and let Y represent the amount of the 10% in milliliters. Okay, so let's think about this. We have two totals. We know that we want to make 250 milliliters, and we know that we want it to be 8%. Okay, so if these are each in milliliters, it makes sense that our first equation is this. Let me write it and then I'll explain. Okay, this is 250 milliliters. So it makes sense that we have milliliters plus milliliters equaling milliliters. Okay, you might even want to write that underneath. Milliliters plus milliliters equals milliliters. Okay, the units should match. I'm talking about this because our next equation is a little bit trickier. So if we have our 5% acid times the amount that we put in, and then our 10% acid times the amount we put in, a lot of students just write this, the 8%. Now, what is wrong with this? This is incorrect. Because notice here we have a percent times milliliters, a percent times milliliters. And here we have a percent times milliliters. So it doesn't make sense to have that equaling only a percent. We also need a milliliters next to it. So how many milliliters do we put there? Well, we put the 250. Okay, so this is the amount of acid in the first one, and the amount of acid from the second one equals the amount of acid in the third one. This is the number of milliliters of the concentration, whereas this is looking specifically at just the acid in the solution. Okay, so these are our two equations. So this one can be simplified to 0.05x plus 0.1y equals 20, because 8% of 250 is 20. Okay, so I am going to not necessarily show the algebra here. We have two equations with two unknowns. You can use substitution or elimination. Okay, I encourage you to pause the video now and actually do it. You should get that x is equal to 100 and y is equal to 150. So therefore, you should use 100 milliliters of the 5% solution and 150 milliliters of the 10% solution. And you can write a sentence. Okay, if you would like me to show you the actual algebra of solving this, please make yourself a note and I can show you tomorrow. Okay? The difficulty in most of these problems is actually coming up with the equations. Okay, here's our next one. So this one has money. So Skittles are worth $2.10 per kilogram, but Reese's Pieces, because they got that peanut butter goodness, they're worth $2.70 per kilogram. So they're mixed together to make 500 kilograms of a mixture, and they sell for $2.52 per kilogram. So how many kilograms of each were used? Okay, so let's think logically again. What's halfway between 210 and 270? Well, they're 60 cents apart, so $2.40 would be the middle point between these two. Notice that it's selling for more than $2.40, so there must have been more of the expensive Reese's Pieces. All right, just to get you guys thinking about it. So let's say, let S represent kilograms of Skittles in mixture, and let R represent the kilogram of Reese's Pieces in the mixture. Okay, so all together, our Skittles in kilograms plus our Reese's Pieces in kilograms will equal 500. Again, this is kilograms and kilograms, so it should equal kilograms. All right, now we have our Skittles worth $2.10 times S. So this is the number of kilograms times $2.10. So this is the total amount spent on Skittles. Okay, and then we have our 270 times R. So this is our total amount spent on Reese's Pieces. So again, it doesn't make sense to put just $2.52. Notice that it's always a dollar amount times kilograms, dollar amount times kilograms. So we need a dollar amount times kilograms. This is the total price spent on the mixture, $2.52 times the 500 kilograms that it is. So we can simplify this to 210S plus 2.7 R, and $2.52 times 500 is $12.60. Okay, so I will actually go ahead and show you how to solve this. So I used elimination here, and I multiplied this equation by 210, and then I subtract the two equations. So you get 210S plus 210R equals 1050, since 500 times 210, is 1050. So I'm going to subtract the two equations. These eliminate as they are supposed to. This gives me negative 0.6 R equals negative 210. So if you divide both sides by negative 0.6, you get 350. So that means out of the 500 kilograms, 350 were from the Reese's Pieces. So then Skittles, so S equals, or I should say S plus 350 equals 500. So our S is 150. So therefore, you can write a nice sentence. 150 kilograms of Skittles were used and 350 kilograms of Reese's Pieces were used. Again, we were right. They used more Reese's Pieces than Skittles. So that is mixture problems. Again, you'll see the two types, one with percentages and one with money. Now you know how to do both. Okay, we're moving on to distance, speed, time problems. So if you want to take a little break and absorb the information from the mixture stuff, that's up to you. We're just going to do examples 7 and 8 for today. And in the next lesson, we'll learn some more complicated distance, speed, time problems. Okay, now the first thing we need to remember when we're dealing with distance, speed, time is our distance, speed, time triangle. Okay, so maybe you learned this in science, maybe you didn't, you should have, but this just means that distance is equal to speed times time, or speed is equal to distance divided by time, or time is equal to distance divided by speed. So distance and speed and time are all related. So if you remember that triangle, then you should be able to remember these three relationships. And that will be very helpful with distance, speed, time problems. Okay, so Julie traveled the 3,590 kilometers from Ontario to Calgary. Okay, so that's her total distance. So let's just write down what we know. So her total distance is 3,590 kilometers. She traveled by bus to Toronto at an average speed of 60 kilometers an hour. So bus was 60 kilometers per hour. That's the speed. And so you could have said bus speed. And then plane speed was 700 kilometers per hour. Her total traveling time, so total time, is equal to 6.5 hours. How long was she traveling by plane? Okay, it's really, really awesome. It's really, really important that you pay attention to what the question is asking. The question is asking for how long, which means it wants us to figure out time. So our variables should be in terms of time, since we want our answers to be in terms of time. So we should say, let B represent hours on bus, and let P represent the hours on the plane. And again, I'm choosing hours and time because the question is how long. That's super important. So now for our two equations, notice we have two totals. We have the total of 6.5 in terms of the hours, and we have, that's a point, and we have the total of 3,590, which is a distance. So our time plus our time is 6.5, and our distance plus our distance is 3,590. Okay, so our variables represent hours. So it's just B plus P that is equal to 6.5. That's what we let our variables be. But now, how do we represent the distance on the bus and the distance on the plane? So this should be distance on distance, I don't know either, on bus, and the distance on the plane. Well, it doesn't give us that anywhere here. However, we know that distance is equal to speed times time. We do know the speed on the bus was 60, and the time on the bus is represented by B. So 60B then is the distance that they went by bus. So the distance on the plane is its speed, 700, times its time, which we let be P. So 60B plus 700P equals 3,590. And this is distance, and distance equals distance. So now we have our two equations and two unknowns. And again, you can use substitution or elimination. They are both totally fine here. So I used substitution. So I let B be equal to 6.5 minus P. and I sub that in here. So 60 times 6.5 minus P plus 700 P equals 3590. Now I encourage you to actually do the math here, but you should get that P is equal to 5. And that's how long she was on the plane. So notice that the question actually only asks how long she was on the plane. I don't actually have to find out how long she was on the bus. Clearly we can see that she was on the bus for an hour and a half, but now we can answer the question with a sentence. Therefore, Julie was on the plane for 5 hours. Okay, one more question that's similar, but you'll see the difference in a moment. So Jack drove 50 kilometers an hour from Wonderland to Awesomeville. Okay, so he goes from Wonderland to Awesomeville, and then from Awesomeville to Funtown. These little diagrams help me. So from Wonderland to Awesomeville, he went 50 kilometers an hour. And from Awesomeville to Funtown, he drove 80 kilometers per hour. He really wanted to get to Funtown. The whole trip was 550 kilometers and took 8 hours. Okay, how far is it from Awesomeville to Funtown? So notice here that the question is different. The question here is how far. So it's the distance that we want to find out here, not the time. So it's this distance here that the question is asking us about. So we want our two variables to be in terms of distance. So we can say let x represent distance or kilometers, we can even just say, from Wonderland to Awesomeville, and let y represent the kilometers from Awesomeville to Funtown. Okay, you can write full sentences. I just have limited space here. All right, so again, we have two totals. We have a total of 550 and we have a total of 8. So this is total distance and this is total time. So again, that's going to be made up of the two distances for each. Now in this case, we let our variables just be distance. So in this case, x plus y equals 550. This is just the distance here. So this is x. This is just the distance here, which we let be y. So that the two distances together is 550. Now, the problem here is that we have time, and we aren't given how much time there is. But we remember that time is equal to distance divided by speed. So the distance from Wonderland to Awesomeville is x, and the speed is 50. Then the distance from Awesomeville to Funtown is y, and the speed is 80. So these individual things represent time, since time is distance over speed. So now we have our two equations with our two unknowns. So these fractions are not great. So what I'm going to do is I'm going to multiply this entire equation by something to get rid of them. Now, what number would get rid of both 500 and 80? Well, that number is 400. So 400 divided by 50, I'm having a brain fart here, 4 is 8. So 400 divided by 50, I get 8x. And then 400 divided by 80, I get 5y. And then 400 times 8, I get 3,200. So I'm going to use this equation, because it doesn't have fractions in it, and this equation to solve this problem. So again, you can use substitution or elimination. I encourage you, again, to do this on your own. And you should get that the answer, so the distance from Awesomeville to Funtown, is 400 kilometers. Okay, that is the distance from Awesomeville to Funtown. So I'm going to check to see that you did that algebra tomorrow. All right, guys, so that's it for today. Thanks for watching. I hope you learned lots.